Hello everyone, and welcome to our session on demagnetizing techniques. At one time or another, we've all used a horseshoe magnet. It has a pole on each end, a north pole and a south pole. It will pick up anything magnetizable, like these paper clips or like small parts. Now, any part can become magnetized, such as this bar. It's magnetized because it has a pole at each end. We can see that pole using a field indicator. And it too will pick up parts and materials like these magnetic particles here.
Long parts should be passed through the coil such that the axis of the part is the same as the axis of the coil. The part itself will tell us how best to demagnetize it. Let's see what happens if the axis of the part is not the same as the axis of the coil. Let's repeat the process now, passing the part correctly through the demag coil. Since most AC demagnetizing coils in the United States operate from 60 cycles, the speed of the part through the coil is not critical.
A single layer of parts in a basket, even though they be various sizes and shapes, will demagnetize properly as you send the basket through the demagnetizing coil. You can even do 2 rows of baskets through the same way. The moment you try it with 3 rows going through, the center part does not properly get demagnetized. Now let's demonstrate this. The center part would get shielded. We'll demonstrate that with 2 parts here. These have been magnetized. I'm going to send them through the coil. This one got demagnetized, this one didn't. In order to properly demagnetize this, it doesn't have the shield around it now. And now it is demagnetized. By the way, don't make your basket out of magnetizable material.
Here are some important points to remember. For best results, your coil demag should be lined up such that the parts passing through it travel in an east-west direction. This is most important on long parts like bar stock or torsion bars with a high LD ratio. If your machine shop foreman is experiencing problems with parts made from bar stock, check the orientation of your bar stock racks. If AC current magnetized it, an AC demag coil will remove the field. If DC magnetized it, and the part has a 2.5-inch plus cross-section, only a DC demag will remove it. The 3 Gauss limit refers to pocket field indicators only, not to other Gauss meters, such as the Hall effect meter, which is used for determining whether a part has been properly magnetized. Parts with a circular magnetic field in them do not have poles and will not pick up metal chips. However, if you try to machine them, the field is exposed and chips will cling. Keep machine tool programmers, computers, display monitors, pacemakers, and your watch away from strong magnetic fields. All AC demags are single-phase units. Strong ones draw a heavy current. Don't have your computer on the same circuit, as voltage drops can and do occur. If you adapt the demag to a production line, look out for induced currents in any support members. Even non-magnetic ones may get hot. Parts with high LD ratios are easy to demag, but squarish parts, those with LD ratios of 1 or less, are more difficult.